Hi, welcome all. Myself, Venkat Srikanth Bandi. So I'm working as a data engineer in a biggest transportation company in Finland. I did my PhD from Aalto University in Finland. So welcome to this workshop, data engineering workshop. The, you might have all heard about the term data engineering. So if you want, in short, data engineering is nothing but ingestion and transformation of data to serve downstream users. So what exactly what exactly it means actually when we say ingestion and transformation of data, we will see with a example actually in coming slides. But as you all might be freshers and college graduates, so I want to say one thing clear and loud. Basically to become a data engineer, you need following skills. You need to know SQL, you need to know Python. If you are good at like Java or Scala, that's also good. If you know a bit of a command line programming, that's also good. But to start your career as a data engineer, do you need to be already expert in everything? I would say no. But you need to know some basics actually, some basic skills, and you need to be little proficient in Python. That should be good enough to start your career in data engineering. And with existing tools like Copilot, Chat GPT, and other AI tools, it's much easier these days actually to write SQL code or Python code. But you need to have those basic skills to understand and interpret the code that's written by AI tools. So, in brief, you don't need to be already an expert to become a data engineer, but you need to know some basics. For few things, actually, you need to know basics. For example, for some concepts, you need to be intermediate user. That's good enough. You don't need to be expert in the beginning itself. Now, let's look at an example. So let's take a mid-sized company that is operating on Amazon e-commerce platform. Let's assume that company has 50 different products, and they do operate multiple data warehouses. Sorry, multiple warehouses. And then actually they also work with different suppliers. So let's assume a scenario where they have to process around 24,000 orders actually in the working hours. That basically means if you assume like, there are 8 hours actually in a working day. So they have to process around like 3,000 customer orders every hour. That means actually they receive 50 orders every minute. So let's assume actually some customers order multiple products. That means in a day they have to handle around like 20,000 customer orders, which basically means they have to do this 20,000 shipments every day. So while they are doing it, they do have this objective, the business goal. The business goal is more about ensuring the timely delivery for the customer so that actually the ranking in Amazon e-commerce actually it goes up. And whenever a customer searches for a product this company sells, they do come under like, these companies' products are shown at the top. For that, as they are going to process high volume of products every day, they need to have a better inventory management system. So, and this management of inventory is necessary uh, to sustain the business growth. At the same time, they need to have like some financial reporting. At the end of the day, as a company, they do care about actually profit and loss. But the profit and loss, they're it's kind of related with like how many products they sell, how much they sell, and how much inventory they have. What would be the profit margin? What would be the charges they have to pay for Amazon? What would be the salaries they have to pay? What would be the cost in ensuring timely delivery. They have to consider all these things. At the same time, as we already know, I think as I saw all of you are from India, so you might be all know, we all know about this Deepavali Dhamaka sale, or like, some sale, like, winter sale or whatever. So usually Amazon comes up with like the seasonal and promotional campaigns, big days or something like that. So there are like kind of many promotional programs. So in general, what happens is that like during those promotional campaigns, so the suppliers are expected to have enough inventory so that Amazon customers, they can make as many they can make more orders. That means, in order for this company to qualify for the program, they need to keep enough inventory. So in this example, we just look at inventory management as a data engineering problem. How it manifests actually when a customer places an order in Amazon platform. How it manifests. That's what we're going to look at. Here I have highlighted this inventory management. It doesn't mean that actually this problem is kind of isolated problem. So this particular problem, it's kind of it deals either directly or indirectly with other three issues also. For it's related with the financial reporting. It's related with like sales forecasting. How they are interrelated and how a data flow begins when a customer places an order. So that's what we are going to see now. So as I said, like, so inventory management is our data engineering problem, if you think about it. So basically what is the main objective of the inventory management for this company? So first, they have to avoid two scenarios. They don't need to they have to ensure they don't run out of products. That is basically stockouts. When they run out of products, actually, one immediate effect is actually they are going to lose the sales. There is another effect that kind of reduces their business in the long term. Usually, Amazon as an e-commerce platform, they do uh, they do prefer vendors, who have their products always available. If he fails to maintain certain level of inventory, they are going to lose their ranking actually in Amazon e-commerce platform. If they lose the ranking, their products won't be displayed actually, as in the beginning. That means actually customers will buy from a different vendor selling the same product. And that is something actually, in order to kind of avoid that situation, they need to have enough stock available all the time, adhering to the seasonal demands, adhering to Amazon requirements. At the same time, actually, they cannot keep overstock. For example, let's say they are selling a mobile phone. Let's say they are selling a mobile phone, and let's say they are selling like, this is an outdated example, but just as an example, if they have 1,000 Micromax mobiles. Micromax is like, little world mobile manufacturing company in India. If they have like 1,000 mobiles, so nobody is going to buy it, right? In a sense, like there is no need of like having. Let's say they have only two. There is no. Basically, what happens is once they keep those phones overstock, their cash is blocked in the inventory, and if nobody is buying it, actually they are going to incur loss. So in a way, in inventory management, they have to ensure they don't run out of the stocks. At the same time, they don't overstock. Now, as a vendor on Amazon e-commerce platform, they have to ensure there is a performance metric also. They have to ensure this on-time shipping. So basically, if you're a Prime customer, you need to get your product actually on your doorsteps within 24 hours or 48 hours. So for this, actually, they have to maintain like their own logistics. so that those products will reach Amazon warehouse actually within a stipulated time. And at the same time, they want to ensure that, like, by keeping the stocks at a certain agreed level, they and if they deliver products on time, then only they will continue their preference as a preferred vendor. So this is something actually this company want to kind of ensure in inventory management. So this is a data engineering problem. For this, actually, we have to ingest data, we have to transform data, and then we have to report the data. How we are going to do it, we will see actually as the lecture progresses. So for this, actually, as I said, actually, data engineering is nothing but ingestion and transformation of data so that we report it for the downstream use. For the ingestion is nothing but actually uh, reading the data. In much more simple terms, ingestion is nothing but reading the data so that we could use it for information. When we read the data, actually, it's not like actually we could read the data into the air. When we read the data, we have to kind of store it somewhere. So the places actually where we store the data is called like storage systems. Now the problem is actually how we are going to read the data. Amazon, it provides its reports and different APIs for its vendors. Those APIs will help the vendors to read the customer orders, including actually, basically how many products it is, what would be the stipulated time they have to make sure that the order is been shipped to the customer. They should have, they should also, for example, let's say if Amazon is the centralized shipment system, there should be a way so that, like, their product actually will ship from this company's warehouse to the Amazon warehouse. At the same time, sometimes the customer might initiate a refund order. So then actually the company must know actually, they have to receive that particular order again back to their warehouse, or like, there are like some other things. And at the same time, there is a financial aspect too. Whenever a customer places an order in Amazon e-commerce platform, there is a financial transaction that takes place. And there is an agreed fee upon which actually the Amazon charges, and the rest of the money will be paid to this company. So there is always this fees and charges related information that also kind of flows through the data flow. So this is the information actually Amazon provides, either through APIs or like some other means. And then this company must have their own internal enterprise resource planning system. And this internal ERP system, it should be able to monitor and keep track of the stock in different warehouses. And it should be able to have the information on orders and receipts, purchase orders and receipts. At the same time, as this company operates like 50 different sells different 50 different products on Amazon, they should be able to keep the information on suppliers. Basically in how long it takes for the supplier. For example, if this company places an order for, let's say, for a particular product X, how long it takes for this particular order to get delivered to their warehouse. Okay, at the same time, they can't just place like one single order. So every supplier kind of demands that actually, we will supply you this particular product only if you order 100 items, only if you order 1,000 items. There would be some other constraints like that. At the same time, they should also keep track of, like, let's say Amazon wants to come up with like this Deepavali Dhamaka sales or something. They should be able to they should be able to guess how many customers might order a particular product, and they should kind of stock the products. in a level so that they can adhere to the customer demand. So these are like kind of, there are like kind of different data sources actually within the system. So now let's draw together what happens when a customer places order on an Amazon. Okay, this is a basic block diagram I have made. Okay, so now we will see actually how when a customer places an order, what kind of a data flow, how data flows between different systems. This is a simplistic block diagram. So whatever I said, let's try to understand. I will reiterate what we are going to do now. So we are talking about a mid-sized company operating as a preferred vendor on an Amazon e-commerce platform with 50 different products with the different multiple warehouses and suppliers. So this is the context. Let's draw what happens in terms of data flow when a customer starts. So basically, these are the terms actually, Amazon has its own data platform. Data platform is nothing but actually like, collection of data. Just think it like that, it's in a much more simplistic term. And Amazon has their own data platform. They are quite big. I mean, they work at like different efficiency level because Amazon might receive orders like, a million orders per hour or something, their scale, how it is built, it's little different. Now let's just understand actually how this company's internal data platform will work. Let's say in the beginning, what is the initial point? So the initial point is actually here, the customer places the order. But for this customers to place the order, so basically, here we will start drawing actually the data flow. First, whenever customer visits Amazon.com, let's say Amazon starts showing actually a product this company is offering. Again, each product might be available in like either in different dimensions or different colors, or different variations, right? So this information is available in terms of the product availability. So let's say a customer saw that actually this product is available. That means actually this particular company product is being shown and he decided to make a order. So let's say he clicked the order and then basically after he clicked the order, then he's been directed to like this particular fees and charge, right? Like he is directed to do like this thing. He has to make the payment. So after this payment is being done, let's say if it is successful, then it basically kind of he gets this information that like your order is successful and you get like so and so you will get this particular product with a in particular he should get a shipment details. Let's put like in much more simple terms, he should get like shipment details. Then so this is what is being shown to the customer. He is being shown only like you place an order, you made the payment, this is your payment is successful, and this is your shipment details. That's what happens on the foreground. While this is happening in the foreground, something also happens in the background. Okay, so now let's say this is after this has been successful, so we will be get notified. Okay, you should be ready to ship. You should be ready to ship this particular product. So this actually we get a message to our order management system. Okay, and then actually after we get this order management system, while we also get like some other information as well. Let's say we have to ship it ourselves, for example. We get some other information. What we will get? We will get actually what product we need to ship, product type, product we have to ship, and basically how many And then we might also get like actually, let's say let's assume like a simple example. We have to kind of send it to like some Amazon warehouse which is nearby, or like or a customer Amazon warehouse address or customer. Let's go for like customer address, so that like it's much easier. Okay, so then actually after getting this, they need to know, basically then that system need to know basically this info, and we have our in-house warehouse management system. We have to ship that product from, as we have multiple warehouses, we need to kind of send this data again to the warehouse. Then we will decide actually, where we, from which warehouse actually we are going to ship it. Let's not think about actually what happens into the warehouse management, but then actually after this has been done, then somebody, one of our the company's employees, they does something actually inside the warehouse management, and then they kind of make it ready, and let's say they ship it. It's not necessary that actually they just ship it, right? When they ship it, they need to again note down, basically some sort of a tracking number. They should provide like what would be the address. Okay, let's say for shipping. Now, when we start sending the shipment, it's like kind of, then we need to also kind of have like some sort of a some sort of a ID in, some sort of a tracking information, or like some sort of, it has its own information that's also need to be sent from orders to warehouse management, right? I mean, again, it would be much easier to send that information from orders to shipment already. You understand actually what I mean? So basically the same order information will also go to the shipment. Whenever they receive some product actually from the warehouse, then they are going to do some matching actually, like, there will be some data, they match the data, and they ensure that actually, okay, this shipment is, this is the product actually where we need to ship. And then they should also need to know basically, so this is what they do. They again, let's say they have to send this information to Amazon data platform, so that it updates the shipment whatever we see there in the website, after product is been dispatched. So it would say like, it keeps on updating actually this information in Amazon website. So this information has to be kind of not in real time, near real time. What is mean by real time and near real time, we will see later. Okay, this is something they have to see. At the same time, let's say from a warehouse point of view, whenever, let's say we have 50, let's say in our warehouse, we have 50 products in the beginning. At the T0, we have 50 products in the warehouse. So at T1, a customer ordered it. Customer order came. And then actually at T2, we have shipped it. Then what should happen actually at T2? It should update it, so that like, it should be like that is 50, the number of products in the inventory should become 50 minus 1, which is nothing but actually it should become like 549, right? And this 49 should again start reflecting in the product availability in Amazon. Okay, and let's say this becomes 0, or like let's say at like some at some other time, let's say like T100 or something, the number of products became 10. So we have only 10 products. Let's say Amazon mandates that actually we should have at least 10. I mean, we should, after a time, we should maintain at least 40, let's say. Then that means actually we have to make an order. right? We have to make an order for this particular system. Again, for making an order, we have to initiate some other activity to the suppliers. And after suppliers actually again sends us data, let's say he kind of gives us information through shipments. Then actually again after receiving it through shipments, then it should again actually update the information. You know, then again actually this should happen. While these things are happening, the management should have an idea actually what is happening inside the company. So there should be some sort of a indicators that they should be start showing. You know how many customers actually are kept on ordering order on this particular day. If a number of customers dropped actually on a particular day, why they have why what was the reason? Is it because actually Amazon may no longer is accepting as a preferred vendor or not? Or do we have enough products on the shelf? You know that is something actually this particular department will do. So this is the another aspect. And then on a side, there is a financial department. The finance department also should need to make sure that like actually they should at least pay to the employees. You know, they should keep track of how many employees. Let's say Deepavali Dhamaka sales are coming. Let's say Amazon said like you might expect like uh, twofold increase in your product demand. That means you need to employ new workers. Okay, you need to kind of have an additional warehouse. Okay, you need to have an additional warehouse that you need to put in. So there is a kind of a different things goes on. At the same time, they should also keep track of the money, the revenue that they are going to get from Amazon. Okay, and then Amazon have their own systems of maintaining the inventory. I mean the financial transactions and stuff. So as you can see, this is only, when one customer does the order. When multiple customers are making order, when multiple shipments have been delivered, when we are handling like, let's say, uh, let's assume that actually a customer, he got the order back and then he is not satisfied with the product, then he want to ask for a refund. Then again, for refunding, actually, there is another process. There is it kind of comes a information again to the order management system. Then they have to increase the number of products in the warehouse. Again, they have to kind of issue a ticket actually, so that like a customer should get an address notification, to which address this shipment has to be delivered. And then actually, if there is something, we have to pay back the money actually. Then we have to again pay it back to the Amazon, and then again an Amazon actually pays it back. So usually whenever a customer clicks something on Amazon website, there are 100 different things happens in the background. And whenever these things are happening, some data somewhere is either modified or transformed. For example, a good example of transformation is, for example, shipment. In shipment we will see waiting for someone to pick up, waiting for the courier to pick up or something. So whenever he picks it up, that particular state has to be transferred to like on the way to customer address. So that's there is kind of so many different things happens in the background. So you need, as you can see, the complexity of data flow here. you know there is a data that's moving from one system to other system. Sometimes it's adding, sometimes it's subtracting. Okay, sometimes it's a state variable changing. So there are so many different things. These things, how we are going to automate it? That's the central question actually of data engineering. How we are going to ensure that these the data flow across this different across these two platforms, how we can ensure that this data flow is consistent, efficient, and at the same time it should help the management to take better decisions. So this is what data engineering is all about. So for this, I hope you understood actually the data flow here. Any questions actually at this point? Any questions? Okay. So let's go back to our lecture. Let me share the slides again. So as I explained, actually, whenever customer places the order on Amazon, there is a data flow that happens between Amazon data platform and the company's internal data platform. So how do we automate it? So that, like, as I said, the data flow is efficient and transparent. At the same time, it should help management to take better decisions. So this is what the data engineering is about. So how they do it is something actually you understand when you become, when you get trained as a data engineer. So as a data engineer, you need to know at least few key terms. The first and foremost important term, ETL or ELT. ETL means extract, transform, and load. ELT means extract, load, and transform. Extract is nothing but ingestion. Loading is nothing but writing it to somewhere, some database or like some tool, or some storage. Okay, transforming is basically actually, as I said, like let's say in a shipment, there should be a status change. It's nothing but a transform. And then we have there is another term you need to know. This OLTP and OLAP. OLTP stands for online transactional processing, and OLAP stands for online analytical processing. Okay, the key stack, the technical stack actually that Surendra is going to present, it's going to explain what is OLAP in much better terms. But in general, assume like this. Let's say we were at a we were in a shop, and then we swipe our card to make certain payment. Then what typically happens in the background is an example of OLTP system. For example, what happened in the background when a customer places an order, that's an example of a OLAP system. Okay. And then there is another term actually you will be hearing, like you will be using every day when you become a data engineer. That is nothing but actually data. That term is data pipeline. So what data pipeline does? The data pipeline, they ingest, transform, and load data either using different tools, different orchestration tools. Let me put like this. What is an orchestration tools? Basically these orchestration tools, they help schedule, manage, and automate the data flow and the processing of data across multiple tasks and stages. And they have to ensure that actually everything happens in a correct order at a right time under right conditions. For example, this is the order, after customer receives an order, after he receives the package to his home, then only actually it should change, it should change the status to received. That's an example of the condition. So these are the four different key terms actually you need to know. So let's look at like what is a data pipeline. A data pipeline basically automates the flow of data from source to destination for processing and analysis. And now let's look at like few more terms actually that we use in data engineering. Okay, let's say there are certain data that we have to process in real time. For example, whenever customer makes the payment, he expects that actually whether the payment has gone through or not immediately. Okay, so that type of financial transactions, usually people expect to show the output or outcome in real time. Whereas when it comes to shipments, you don't need to update the shipment every second or something, the status of shipment. You can update, like, let's say if you're delivering like 50 orders, you can update the status of those 50 orders actually, let's say after every 30 minutes. Whenever you kind of define a stipulated time for particular, for combining different items together, and you execute the pipeline at a particular stipulated time, then it is called like batch processing. For example, those of you who have used online banking in India, you might be knowing actually this IMPS transfer and NTFS or something, or RTG. You have like different money transfers, right? In IMPS transfer, the bank uses additional resources for doing this real-time transfer. Whereas actually, if you kind of opt for NTFS payment or something, I don't remember the exact term, then usually bank kind of does this batch processing for all payments at once. So it's basically about, that's why they usually charge extra for IMPS payment, because IMPS requires dedicated resources. Whereas in the batch processing, actually, they could really do it all transactions at once. It's much more efficient. And again, the transformations. Sometimes actually the data could be, the data might have like duplicates or incomplete information. This information also need to be transformed. If you have duplicates, we have to remove it. If we have incomplete information, then we need to know how to handle it. At the end of the day, what data engineering pipelines does is they take the raw data and they convert the raw data into a useful format. Let's say if I'm a CEO of that company, I don't really care how many products are there for how many a particular product, how many are there in a particular warehouse. I don't really care. As a CEO, actually, what I care is that actually whether I have my own. A CEO might have his own her own uh, KPIs. So he would like to see actually how many timely orders we have delivered. He doesn't go and see like he is not worried about a particular order. So at the end of the day, the raw data that's available in the company's data platform has to be transformed into a particular metric that the management requires or the downstream users require. And at the same time, we also have to store the data. Usually, where we store the data, it's called like data warehouse. There is again actually in modern technical stack, we have data warehouse, data lakes, and data lake house. We will see briefly what we meant by that. And then at the same time, as I said, when we transform the data, we have to transform the data into a useful format. The most useful formats are like kind of dashboards or Power BI reports. You will see in the technical stacks, Surendra presents, we have ClickHouse, which is basically a reporting platform. And so again, in the data, and there is another term that you need to know, it is basically data architecture. So in data architecture, the most traditional solution is data warehouse. And recent solution is data lake. And we have data lakehouse. Data lakehouse combines the features of data warehouse and data lake. So you will see, these are again like just terms. You don't need to, these terms like they are very simple. Don't really worry about like, what does it mean by this? So they are very simple. And the same thing that I have explained in the data flow, if we look at it as a ETL flow, this is how it looks like. Okay. So we will have different methods, either we are going to do batch streaming or real-time streaming. This is something we have to see. And again, there is this full load and incremental load. Full load means actually every time actually we kind of sweep through the whole raw data. Incremental load means actually we don't sweep through the whole data. For example, let's say we don't update our inventory every second, rather than actually at the end of the day, we are going to sweep through, we will do all transactions in the inventory management. Then we subtract how many items are available, or like let's say if we get we are going to ensure, we are going to accumulate the data, what we have yesterday, and how many products we have shipped, how many products we have received from the supplier. We are going to do some cumulative analysis and then do the incremental load. Okay. In the case of full load, actually what we do, we start at time zero and then kind of process everything at once. So that is not efficient. Again, depending for certain situations, actually, there will be scenarios you might need to do full loads. And let's leave out slowly changing dimensions. And as a data engineer, what you do, as I said, we have to transform the raw data into a useful format. That particular process is usually we do adhering to business rules and logics. So this is called data enrichment. So usually the most popular way of data enrichment strategy in data engineering is medallion architecture. Medallion architecture is something, we all know actually, I mean, whenever we are into a competition, actually, there is someone who is going to get bronze layer, someone who is going to get silver medal, there is someone who is going to get gold medal. Basically, it kind of follows something similar. So there is this bronze layer of data we are going to maintain. We have maintained silver layer of data, gold layer of data. Just assume it like, in simple terms like this. In bronze layer, we are going to store the raw data. In silver layer, actually, we are going to transform the raw data into a format that is ready for gold layer. Okay. In the gold layer, actually, basically, we are going to do, let's say, gold layer, the purpose of gold layer is to serve the reporting layer. Okay. For example, as a CEO, a CEO might be interested in seeing what would be the total sales in a particular month. So which basically means actually the data engineer should make the aggregated information readily available or nearly readily available state in the gold layer. That's what actually a data engineer need to do. And as a data, as you become more experienced, so you also need to kind of plan for data warehousing, basically how we are going to read the data, is it efficient? Do we need to do full load? Do we need to do incremental load? These are certain things actually you need to kind of look after. This is kind of a little bit advanced actually, the data warehouse planning as a data engineer, but it's also good to keep in mind data engineers, they also do part of data warehouse planning. For example, if you are working in smaller teams, that's what you do. Okay, I hope you kind of understood. I hope so. This is basically a brief introduction on what it means to be a data engineer. Thank you very much.
Thank you, Srikanth. That was really a very good info session about like what is the data engineering in a very nutshell. Okay, so yeah, just to give a quick about a little bit. So the data engineering jobs are something like you are going to find it in the very near future. For example, if you are a student here now at this moment, for example, you concentrate on this data related thing. So by the time you come out of the college, for example, or like when you're trying for the job, having these data engineering skills with the data engineering technical stack, definitely it will give very good advantage for you. Okay, so we strongly recommend you like getting the, just like in AI, for example, if you want to go into the AI stream, that is one way, or like if you want to go into the data engineering stream, that is another stream, like which is having a very hot jobs in the coming market, because the data has been increasing in million folds actually. Like you saw that, like how much Instagram messages videos you browse in a day, for example, or in a period of time. So every time you click on something, it will generate a data. So how can we process such a large volumes of data for the business use? Yes, okay, so the data engineering is the solution, for example. Okay, so as we learn the basic concepts of data engineering and what is meant by data, how the data flows, and we also get a word called like ETL, and we talked about like extraction, transform, and loading. Okay, so and then like when the data moves, okay, so in the real world we use a lot of tools actually. Okay, each company will use a different tools, and no tool is less than the greater or like less or something. So each tool is having their own market, and depend upon the company. Okay, so the people will use various kinds of tools. So the main idea for this tech stack, like what we are showing here, is like, okay, keeping the freshers and students in mind. So there are many tools like which is available in the cloud. Okay, so you cannot go and take it from the cloud, because they are paid, and you have to put a credit card or debit card there. Like if you misuse, if you try to use those tools without knowing the side effects of it, you might end up with a big bills. So what we want to do is like, let's have a core understanding about the data engineering first. Okay, and then learn the tools like which addresses the data engineering problems. So once you have this understanding, like using of any tool is the same almost, because like they follow the same they build on the same platform. Okay, so this stack will provide you option to learn by yourself in your local. Okay, it means that you don't need to pay a single paisa to anyone. Okay, so you can just we kept it as a stack, kept as a open source. Anybody can download it, and then run it in your local, and then practice this data engineering things like if you'd like. So today, like in this technical stack, what primarily I'm going to address is going through this technical stack, and then introducing each tool, and what is this tool capability, and how to use it, and where to write a code if you want to write a code. Okay, so how to verify it, like that the code is working. Okay, so this kind of a in and out information. For example, like as Srikanth mentioned, that like how to create a dashboards, okay, when the data is processed. Okay, so looking at the, for example, data lake. Okay, so what's the data lake means, like, okay, what as Srikanth mentioned, okay, don't worry about these wordings like data lake or data warehouse or something like that. They are only on the same. So the things that provide to you. Okay, for example, let's say, for example, if you don't know anything about mobile, then you say that Android, iOS, okay, how that it sounds like. They provide the same mobile functionality, but okay, the features of that one might varies. Okay, so the similar way, okay, when you talk about the data lake or data warehouse, okay, so these kind of things, so they address the problems of the other ones and then try to solve it. But that problem solution is the only solution for the market? No. Still, data warehouse is a acceptable and usable mechanism. Data lake is an acceptable and usable mechanism. So means some companies may use data warehouse, some companies may just use the data lakes, okay, or anything else. Okay, so but this is only the concepts wise, like they varies, and the purpose of that one will be varies, like depend upon the business. So today we are going to learn this technical stack. Okay, so and we'll go through that, like what exactly this technical stack contains. Okay, so here is our stack. So how many of you anybody of you heard or used any of this? So there is a Jupyter notebook. Okay, so Jupyter Notebook might be the first one, like in case, like if you are drilling into the Python, or you're drilling into the machine learning. Okay, then the first thing like you might come across is the Jupyter Notebook, or maybe you might heard about the Colab, for example, Google Colab. So the Google Colab also the same like Jupyter Notebook. Okay, so tailored for the Google purposes in the cloud, but otherwise, like, yeah. So these are the stack like we are going to use, and this is very hot tools actually in the market. You go and search with like jobs on Airflow, or jobs on the Spark, okay, jobs on Kafka, okay. So you ClickHouse, Superset, okay, you will find a lot of jobs now. You will find really a lot of jobs now. They are very good, sexy tools. I would say that, like, okay, when it comes to the data engineering. Okay, so we will go through each one of it and then we try to understand like what is that. For example, like Shikant mentioned about like, ETL, for example, extraction, transform, and loading. Okay, so these are like ETL are a independent task which are, you write something and then, you make that action work. So to make that action work, okay, so it has to run either in some particular fashion. For example, you first do extract linear and then transform linear and then load. Okay, so which is done in the linear fashion, for example. Or maybe you want to extract once and transforms in a different way for the different purposes and then load all together. Okay, so or like you extract, okay, and then when you are transforming, like, okay, this transform works, okay, then do a different thing, for example, means like the conditional, for example. Like this, it might be any kind of like workflows if you have. So those will be implemented through the Airflow. So Airflow is not a programming. Okay, Airflow is more like a configuration. Okay, so in this configuration, you write a configuration formatting like, okay, what need to be done, what after. Okay, so then the Airflow will become as available for you, and then you can run these workflows, okay, either in a scheduled manner or like, user initiated manner or like event based, okay, anyway, like, okay, whichever the way you want to run that workflows, you use this Wireflow to do that job. Next comes to the Spark. Okay, if you heard about a little bit about like Python and ML and Pandas, for example. Okay, so for example, okay, so to address some couple of the problems there in Pandas, for example. So the Pandas generally, do the job in a linear fashion. Okay, so when we do the job in the linear fashion, the biggest problem is the time constraint. Okay, so it takes really hell lot of a time when you processing a large data. So what it means that like we need to make it run in run it in a process, for example. Let's say, for example, like you want to calculate average of your marks, for example, okay, in your class. So generally the system, what you do, like, okay, when you write a program, you take each class and then you do the average of each person, for example. Let's assume that to do that just for a discussion purpose. Okay, so let's assume that like you have a like each average calculation take like half an hour, for example. Okay, and then you have a 10 people in your class. Assume that like how long it takes. So it takes almost like 5 hours. Okay, and if you want that to cut down by, for example, let's say 2.5 hours, then the two persons has to take five persons from your class, and then they have to do the calculation. And if you want to really make it in 1 hour, okay, then the 10 people has to work on that one. Like that, it means that either you have to increase the number of people to make it fast, or you use only one resource, take longer time. Okay, so exactly the Spark address this kind of a thing. So the Spark is basically a infrastructure, I would say that like, okay, or a framework where it will take the task is as to do a parallel processing job on the data sets. A data set is your marks, for example, your classroom marks. Okay, so to do that job, you can have like any number of processors, okay, distributed cluster, and then you assign a task. That our task will be, okay, intelligently assigned to the respective instances and then get it processed within no time and then give the results to you. So for such kind of a large volumes of data, you want to run it. So your computer, for example, the laptop what you are using is not enough for doing the job. So you need a better system, okay, with a high parallel processing. So the Spark is the one is used for that purpose. So even in the Spark, you don't, okay, basically for doing the job, you write a code, but Spark as a cluster, you don't do it. You just use that system. That's it. Okay. So next is the Kafka. So for example, like we discussed, if you're doing a payment, for example, through Google Pay or like Phone Pay or something like that, millions of transactions will be created. So when you have such kind of high volumes of transactions is created, you never go and directly put it into the database, because Databases are like whether whether they will go in a row locked or column locked. Okay, when you're doing this kind of like transaction process, updating the database is a very complex and pricey thing as well. Okay, so when it comes as a pricey, it means that not in terms of money, but in terms of the resources like CPU or memory, some kind of thing. So what they do is like they will take a middle stage, a staging stage or middle stage. When the transaction happens, first it will land up in the queue, for example. Okay, let's say, for example, if the new movie is released, for example, and I mean, like in the olden times, now you can buy it online, but in the olden days, okay, so what you do, like you go and start it in the queue. You will not ask everybody to come and take the ticket from the ticket counter. So you ask them to sit in the queue so that you can process one after the other. So exactly, this Kafka is primarily used for such kind of purpose. And something event can be anything, like whether you scroll the Instagram video, or like you do the Google payment, or you click on the browser on some button, everything is an event. So when the event is generated, that event will be first stored into the Kafka and then it is processed. Okay, so that purpose the Kafka is used. Next is a Trino. Trino is a distributed SQL engine, basically. So it's just an engine. It doesn't do anything by itself, but it will provide an engine where you can run the SQLs on a large data volumes. So when I say that large data volume of data, amount of data, that data need not to be coming from the database. Okay, it can be a flat files, or it can be stored in a cloud, okay, or it can be in the data warehouse, okay, it can be in anywhere. Okay, so if you want to run a query on those kind of a data, okay, so we use the tools like Trino to do the job. Next is the Hive. Hive is a metadata store, because when you learn more about a data warehouse and a data lake, okay, so these kind of things, Hadoop, for example, if you learn these kind of things, okay, storing, let's assume that I'll put it in a very simple way. Let's say, for example, you have a computer and your brother is having a computer, for example, okay, and you both like movies, okay, and that's a very bad example, but still I will tell that one. So you download the movies, okay? You download the movies from YouTube or something like that. You want to store it. Assume that like you have your computer is filled with 50 YouTube videos, for example, some movies, and you want to download the 51th one. So where is the space for you? You don't have it, okay? So now what you do, like you ask your brother to download that movie. You'll also download it. So maybe it's also like 150 movies. So now 100 movies are there. The very first problem is, if you want to watch a movie, how do you know like which movie is where? Okay, the first problem is you can't have like more than 100. Okay, and the second problem you have is like which movie is there, where. So you have to maintain some kind of a index somewhere saying that, okay, this movie is in the first computer and this movie is in the second computer, for example. Okay, so that is called the metadata. Okay, and then these metadata, okay, this limitation of this, the disk space or whatever it is, for example, okay, it will enlarge to many computers, or like many disk spaces in the data centers. Okay, so to have a catalog about all those kind of data, so we use like a metadata on as a like a layer. And then, for example, Trino use that metadata to go and query that particular data for us. Okay, so the Hive metadata is used for that purpose. That is the purpose of the Hive. ClickHouse. ClickHouse, as like Shrikant mentioned in his one example, like, okay, ClickHouse provides that OLAP database. It's not a transactional one. So basically, you use this OLAP related, for example, the column oriented database, so that like, we can retrieve the data really very fast, because it's not a transactional. So it is not like a row level kind of thing like a MS SQL or MySQL. It is a column based database, so which primarily used for the analytical purpose. So you store the data, for example, if when the user click on some product, but he didn't buy, but he just bought it and then he closed it. Okay, let's say he spent like 3 seconds and then he closed it, for example. So now the companies want to know that, like, okay, this one user is opened, okay, this product for 3 seconds and then he closed it. So that will give a information. So if like millions of such transactions are coming into the system, so how can they analyze it? How can they query it really fast? So for example, the ClickHouse is the one, like, which the tool which is so popular nowadays. Like, okay, so this one will be used in the for the purpose. Superset. Superset is for example, if you heard about the business intelligence from the Microsoft, for example, anywhere, okay, this will do exactly the same thing, basically used for the data exploration and visualization purpose. So it means that you can create a dashboards and then you can present the dashboards. You can have a clickable, you can drill down into the dashboards and then get into the another data, for example. Okay, so for that purpose, this superset is used. Jupyter Notebook. So for example, when you are creating for example, when you're creating a machine learning model, okay, so in your college, probably when you write a program in a C language or a Python or something like that, you write entire code and then you compile it. Okay, so for when you're working in the machine learning, the problem with that approach is like running everything. So you have to run, the cursor will move from the beginning of the program to the end of the program. So there is no middle ground for the cursors. So it's very difficult, or like, it's very time consuming. Okay, so to run for the machine learning, because every time you have to load the data, the model has to run, you have to make it learn, and then from the data we got, you have to do some other programming you have to do from the beginning every time. So to address these problems, these Jupyter notebooks have come into the picture, where you can halt the cursor for a period of time. Okay, so that, like, you can make that cursor either to run the same line again and again, or you move to the next one. It depends purely on the user, user decision. So if the cursor want to run the same again and again, okay, so you can run it, or like, you have to move to the next line, you can make it. So because of this flexibility, okay, so this Jupyter notebook will become a very famous in, especially for the machine learning kind of things. Okay, so that's a notebook is the one, like, which might be interested. This is a place where you write a Python program, whether you're using that Python program, the program in the Airflow, or using the Spark. Okay, okay, or like, whichever the places you use, or like you're accessing the ClickHouse through SQL or through the Trino. Okay, you use this notebook to write a code and then you access it. So the next one is the local stack. The local stack is, like for example, AWS, which is a simulator. So primarily in these exercises for the data engineering, so the most important thing is here we're talking about the data and the data lake. So here our data lake is S3. So it means that in AWS S3 folders, we stores the data and then retrieve it and then, process it. So this is the stack, like, we use, and we use in this particular stack, and then we'll go through these tools and then try to understand this one. Okay, so this is the stack architecture, where you see that this is exactly almost the same thing like what Shrikant has shared with us. Okay, but it is a more of tool based. Okay, so how this stack has been. So we have a Spark cluster in this stack, and there is a AWS S3, and we have a Postgres database. We have a superset for the BI UI, business intelligence UI, okay, where you can, read the data from the Postgres or like from the ClickHouse, and the Airflow, where you do the orchestration of those pipelines, for example. Okay, and that orchestration pipelines will use the Spark cluster to take the data from your data lake, for example. Okay, and then process it and then put it again back into the data lake. Okay, or like, you have a Kafka, for example, like where this product price updates are coming, or like orders are coming from the outside world, like when the user click it, like user click, for example. Okay, or like you have for example, Trino, where you can, access this data lake data using Trino, for example, which is similar to Athena in AWS. Okay, so yeah, this is a whole architecture of that one, which we are going to see it in the next half an hour or 1 hour. So, okay, so we will go through each tool, and then we try to learn one by one. Okay, so before we go, like I may jump not in the order, but I will jump first. We'll go to the Jupyter Notebook. So as I mentioned that like Jupyter Notebook is the one like which you might be the very first thing you will encounter as you go progress in your studies. Okay, which is primarily used for the data interaction, writing like code in the Python or okay, some other language as well. So you can use this Jupyter Notebook for simple data analysis in your local before you put it into the work. Okay, basically ideal for the teaching or like prototyping or experimentations, for example. Okay, you can use this notebook for that one. Key concepts are like basically you should know these interactive cells, okay, and how to write a code and then run block by block. Okay, so write a notes for your code. Okay, and then look into the visualization, for example, like using like data frames or some data visualization tools, okay, which is available in Python. It's a kernel based, as I said that, like, okay, so it use the kernel and do the cursor. You can control the cursor. Basically, this is the most important thing here. So you can control the cursor and then and then work on that one. So now look into the before we get into the Jupyter Notebook, we will check it about the stack here. Okay, so the stack is, as I mentioned in the meeting invite as well. Okay, so there you can get the stack from, for example. Okay, so I already shared you the stack. Okay, so where you can get most of the information. So this is the stack. You can it's a Git repo. You can you can download this repo. It's publicly available, and then have given a very good documentation on how to start this stack. Okay, so what you do is you just clone this repo, and then you run this file first, so that it will download the required files needed. Okay, and then you run this command. Okay, environment up, then you will see that there is a dashboard comes into the picture, and then you see there is a URL which you can click on that one, so that like you will get a dashboard for you to practice. So now let's look into the stack. For example, it is the one like, okay, so I'm just bringing the environment down here. Okay, I'm just bringing the environment down just to show you. Okay, so currently I'm bringing the environment down, which is there again in the documentation, how to bring your environment down. Okay.
Yeah, Surendra is trying to reboot, I guess, like install it.
Hi, can you see my screen?
Sir, not visible, sir.
I could see the screen.
We can see.
Yeah, we can see the screen.
Okay, sorry for the trouble. Okay, so just give me a second. Like, okay, yeah, I'm sorry. Like something happened to my computer all of a sudden, so it was hanged. Maybe because I opened too many browsers or something like that. Yeah, so I'm just bringing the stack up now. Okay, so as I mentioned that like it might take a little bit longer for you, depend upon your system, computer resources and all. Okay, so in my computer approximately it takes like 5 minutes to 10 minutes, like if we are running it from the scratch. So if it is a restart or something like that, it doesn't take such a long time. Even for you as well, if it is a restart, it doesn't take a long time. But first time, definitely it is a time consuming process. And if you are on Windows, for example, So you need to have that Docker running in your subsystem, for example. Okay, and you have enough RAM memory. Okay, so when you get a knowledge, you don't need to up everything. Okay, you can tailor it only the things like which you are learning. Okay, so that like you'll have a more understanding about each component. But here, like, as I say, as for a workshop purpose, so I have to enable everything. Okay, so I'm just doing it. Okay, so yeah, for example, if you look at this airflow in it, okay, so this is one of the the initial component which initiates this workflows related stuff. So that's why it takes a little bit longer time. Okay, so and then we have to wait for until that particular thing is completed, so that like we can get a desktop on that one. But it shouldn't take a long time. So meanwhile, let me open the browser. I think somebody's having some question when I joined. So is there something?
So, I was asking about this repository. So I just cloned it and wanted just check that init.sh file. So where do I find it?
Yeah, for example, this is the stack here. Here you see there is a .sh.
Okay.
Okay, so yeah.
Thanks.
And so let's check. Yeah, so that is completed. It shows exited, but the expected the status is the right one, because it has to do some process and then it has to close down, so that like it will allow the API server and the DAG processor, triggers, schedulers all to go forward. Okay, so if you see this one, it is an expected one. So once this is completed, this will be quicker. Okay, so if you are aware of AWS, for example, S3, okay, so okay, so here we have, as I mentioned, that like we have a local stack which is running in the local. Okay, so which provides like S3 access, so that where you can you can access the tables. For us, like when you talk about the data lake, or like, okay, so for example, we can assume that this demo bucket or like clickstream bucket is as a data lake. So all the data whichever we talk about will be stored in this one. Okay, now the stack is running. Okay, let me go to the browser. Okay, let me. Okay, so what's this browser? Yeah. Okay, so now once this is up, okay, all you have to do is just click on this one, so that like you can get a dashboard here for this one. Okay, so in this one, as I mentioned, that like the very first part for us is this notebook. Okay, where you are going to spend most of your time when you're doing the data engineering job, means like you are writing a code and then doing it. For example, when you click on this Jupyter notebook, so it will just open a Jupyter notebook where you see there is a work folder. Okay, so this work folder contains a sample code where you can, if you want, just to even check whether like this stack is running perfectly fine. You can take these examples and then you can run it and then you can see that one. But I'm not going to run it at this moment, because like, okay, so first I want to explain is what is what. So for example, when you open a stack like this, okay, so the notebook, so you see that there is a print command, which you can see a Python code here. So you can directly run this Python code and then see that like, okay, it is working. For example, Right now it is using the Python 3 as a kernel. Okay, there we have this one. So for example, if I run this one, so you see this is the print command happens. For example, if I mention like let's say for example a equal to 1 plus t and then print a for example. So you write a code like this in the Python and then you run it and then you see that like okay, the 3 is there, the value, for example. That is how you write a code in Python. So which I don't need to clearly need to teach you the Python, but the main idea is not that one. So this notebook is especially used for that purpose. Okay. So now when it comes to the stack, okay, so as you saw that one, we have here the stack, for example. Okay, when you okay, so when I show either like this visual code, or like if I show the visual code, or if I show the GitHub this one link, okay, they both are same. Okay, so depend upon the users, like I will jump from this and that. Okay, because okay, so you see the folder structure, what you see here and the what you have here, they're exactly the same. Okay, so don't get confused when I'm showing this visual code or the browser. They both are exactly the same code. Okay, so only just for to make it simple, sometimes I use a different layout for you. Okay, for example, here I showed you already the notebook, this one notebook, and then I showed you the work. Okay, the work folder. Okay, so work folder. Oops. Okay, work folder, and then you see there is a files inside. Okay, so these are coming when you're practicing. This is the important thing. So those things are coming from stack, code, and then the notebook. Okay, so if you want to write a code or something like that, okay, so if you create a file there, where it will going to store is in this folder. Okay, so just you have to know that like where this stack, where you write a code here. Okay, all the things. So this code folder is shared among all the yeah, among all the stack. Okay, so either you take Airflow or you take a Kafka, okay, or notebook. Okay, this code folder is shared among them. It means that they exchange this code using this folder. But when you come to the real world, generally that has been implemented using some Git. But here for practicing purpose, we are using the shared directory. Okay, so and then let me open the okay, so yeah, now the okay, this is the one, and next thing, like okay, we want to now you understand, like okay, we write the notebook code. Okay, so whichever the code you want to write, for example, you come here and then you write a code here. So whatever the code you write will be executed depend upon like what you're writing. For example, let's say you are writing a Spark. For example, you see it here. Let's say, for example, user clicks. Okay, this is running on the Spark mission, for example. Okay, because like here you are mentioning the Spark session, so that it will connect to the Spark and then it will run. We'll go through that one later. But how you write a code? For example, if you write just a print command, then it will use the local kernel and then you just run it there. Okay, so the next one in the list, like okay, we want to see here is okay, so Airflow. So when you write a code in the notebook, and then you want assume that like you write a code in the notebook for your task, and then you tested it, and then everything is working fine. So the ultimate thing what we want to do in the data engineering thing is like, as mentioned, that like ETL, so extract, transform, and load. Okay, so for extract you write a code and then you test it and then it works, and for transform you write it, you test the code and it's working, and then load, okay, you write it, you test it, and then it's working. So now you want to run this one as a pipeline. Okay, so one after the other. So airflow is the one. So when it comes to the airflow, basically as mentioned that like we use it for the automating the data pipelines. Either it can be ETL or it can be ELT, for example. So ensure that tasks run in the correct order. So whichever the order you want to run, that task need to be run in that specific order. Okay, handles retries. For example, for some reason due to TB is busy and could not able to available at that moment, or like assume that every day morning at 6 o'clock you want to run some job, depend upon a file. If the file there, okay, then you have to write. Otherwise, like you have to retry it often or again, because you know that that file is coming into that particular data lake, and then you have to process it, for example. So retrace mechanism, or like alerts. So when something is happened, like okay, some fail happens, so you want to get some alerts, or rescheduling or scheduling, for example. Okay, so then you can use this airflow. Provides a clear visibility on workflow status. So when the workflow was executed, whether that particular workflow has been executed successfully, and so how do we know that? By visualizing this, the airflow, it provides such kind of information. So in the airflow, what are the core concepts you have to learn? Is the first one is the DAG. Okay, so DAG is a directed acyclic graph. So basically it's a workflow. Okay, it means that like, okay, it takes the standard of DAG, okay, and then the workflow has been designed in such a that in each DAG, okay, we have a task. The task is nothing but a unit of work. So a unit of work can be run on SQL, select this column from this table, okay, and then with this condition, once you get that condition, okay, so you take that data and then do some kind of a, let's say, modification, or like maybe you can just save that one as a CSV file, for example. Okay, so that is a unit of work. So the task is everything is a unit of work where you can write some code to do some task for that one. So for in the airflow, there are like different operators. Okay, so there's a like pre-built ones. For example, like Python, Bash, Spark, okay, or like an SQL. You have a predefined operators also where you can use, so that like, for example, if you want to run a Python program which you write in the notebook, for example, you want to use that Python program as a task, so you use a Python operator. Or you want to run a command line, okay, command line, some command, for example ls, or like, okay, copy all these files from this folder to this folder, for example, okay, then you use a bash operators. Or if you want to run that particular action or like some code in Spark, okay, is also an operator exist in the like that. Airflow contains many operators. The most used operators are like this Python, Bash, Spark, and SQLs, for example. The schedule, so you need to know like, okay, how to create a schedule for airflow, when to run this task. Every day night 12 o'clock, early 6 o'clock, daily 3 times, okay, every day 12 o'clock, okay, morning 3, afternoon 12, evening 6. Okay, for example, Shrikant was mentioning about this payment system like IMPS and RTGs, for example. One is done immediately, another is done in the scheduled manner for all the payments. So that is called the schedule here, for example. Okay, and web UI to monitor these runs and logs. Now let's look into how the airflow looks like, for example. So here is the airflow. So when you go into the airflow, so you can find these credentials in the help document, that is admin. Okay, so oops, oh, sorry, airflow, not admin. So okay, so you click on the airflow. There you see that the user interface, the very first important thing what you need to know is the DAG. So when you write a DAG, okay, that DAGs will appear here. So there is no provision in this UI to write a DAG. Okay, right? You need to write a DAG directly into the shared folder. Even in the real world, you write the DAG in the let's say, for example, in your local, you test it and then you push to the Git. Then this Git will this particular airflow pull those DAGs from the Git and then make it available. So where exactly you write DAGs? So again, going back to the code, okay, and then you see here you can see the airflow. Under airflow, there is a folder called DAGs. So in this DAGs folder, you have to write your DAG, and then so that like you know, I mean, like your DAG will be appear there. For example, let's take one DAG, for example. Okay, so this is a DAG. What it contains is a task, for example, task. Okay, so and then in this task, like what we are saying is extract and then transform and then load. This is a very simple, ETL. It doesn't do anything. Okay, just for the demo purpose. So, but what it contains is, like extract, transform, okay, and then load. So we have definitions here. So you take these two values and then you total them. For example, I just put like I say, total them and then return them like a total. Okay, and then you load that data into wherever you want. Then you write the how in what fashion you want to that to be executed. Okay, in this context, what happens is that extract the whatever we have here will be returned to the value that will be sent to the transform, and then we load that transform value. So as you are calling this main function, okay, then it will execute the task like extract, transfer, and load. Okay, so this is a very simple DAG. Like, but for example, if you go into this one, it is a little bit complex than that one. Okay, so then that one. So it is a if you see here we're mentioning the DAG here, for example. Okay, there are like two ways you can write a DAG. One is a Python based code representation, okay, where you can use the decorators, like for example task, mentioning that total definition as a task with using the decorators, and then you write it. Or like a Python based something like you mention the with the DAG function, you can mention and then you can write it. For example, in this case, in this DAG, what we are mentioning here is we are using a Spark operator, as I mentioned when you're looking into the slides there. So the Spark operator, and then we are telling that okay, this particular Spark operator run this extract, run the transform, run the load. So we write the code here, and then we tell that like, okay, this particular pipeline has to run this particular file to do that particular job. For example, if you look at this ETL, so for example, code shared ETL folder, code shared ETL. Okay, so in this one, so sales data pipeline. Okay, and then we have this extract. So in this extract, we have written a Spark code. So because the sales data is going to be very huge, you cannot run it in your local. But in this case, it is not really the big data, but we have only a sample data there. Okay, but here what we are doing is a Spark code. Okay, so we are defining the Spark. Okay, and then we are reading the data from the S3. Okay, and then we are pushing that data into, for example, we are taking the data from the Postgres. We are doing some kind of a join operations here, for example. Okay, and then we are pushing that data back into the again to the data lake. Okay, so in this one, the extract we are talking about. So what it means that is we are only taking the data. We are not doing any kind of a transformations here, but we are just reading the data. Okay, reading the data, and then we are storing that into a database. So we are taking the data from the CSV file, which is there in the data lake. That is S3 for us, which we mentioned about in the data demo bucket, which we showed that in AWS S3, for example. Okay, and then we are storing that into the Postgres database in this one. That is the extract we are doing. Then the next one we have in the task is the transform. Okay, so what we are doing is we are taking the data from the database again. Now it's from the Postgres. Okay, we are taking that data from the Postgres. Okay, and then reading the commission, and another read we are doing. So this is the data we pushed before, and we are also reading data from another table. Okay, and then we are doing a kind of a join operation here to do some calculations. Okay, and then once we get the data, we are writing that data into the, for example, to the database again, for example, in this case. Okay, we are writing back to another table called temp customer sales with commission table. Okay, and then after that, we are loading the data from that one. So again, we are reading the data from the database. Okay, and then we are doing some kind of an aggregations, group by aggregations here. Okay, and then again we are writing that data into the data lake. The calculated value, whatever the calculated value we take here, will be writing into the data lake. So here the logic is not important. Okay, so logic can be changed. Okay, so why I'm putting into the database for no reason. Okay, so this is not about a real good case or nothing. But what is important here is a pipeline which is having a multiple task. Each task will do some kind of an activity. Okay, and perform in a fashion which you are defined in the DAG or in the pipeline. Okay, so that is the most important thing here. So you have an extract task, we have a transform task, and then you have a load task, and then here is the how you want that particular pipeline has to run. Okay, so there's a start. For example, here a simple one saying that an empty operator with just saying that it's a task. You don't need that one. Just I given that just to make sure that to look beautiful when you say like start and end. And then the task names, extract, transform, and load. You don't need to put the same name there. Like for example, extract, transform, and load. You can use any names. Okay, but the naming provide basically the names will give you a very good visibility for you, like okay when you are looking into the code. Okay, so you created this task and then code is there. So we have it in the DAG and that particular folder where Airflow can read the DAGs. So now if you go to the DAG here, for example, go to the like Airflow, for example. So which one we are looking at? The name of this one is sales data pipeline. Okay, so sales data pipeline. Okay, this is the one we are looking at. Even you can look the code here as well. For example, like okay, what code we are running. Okay, you can even look into the same code like whatever you have run there. Okay, created there. You can see it here. Now here you can see we have a various steps here, like which we mentioned in the DAG, the last, for example. Okay, these things. So you can see that in the order. All you have to do is trigger it. So when you trigger it, so now it will start executing the task which you are provided. Okay, we don't trigger now. We'll come back to the trigger, but try to understand this. Okay, the Airflow is for the pipelines where you write a pipelines using a DAG. Okay, in the DAG, nothing but a task which is written in the code through the notepad or some Python, for example. Okay, and then you provide the input of that one so that like they will execute in a fashion. Okay, so that is what the Airflow do. So now before we go into the into that one, so now let's look at the Spark. As I mentioned that, like okay, so we have written we want to process a large data from the data lake, that is the sales data, and then do this ETL activity. Okay, so then we are using the Spark because we have written the code in the Spark. So what the Spark is for, basically handles the huge data sets across the multiple missions. Okay, much faster than Hadoop, for example. So it is having like unified engine for batches, streaming, SQLs. Okay, this kind of a thing. The key concepts what you have to run is like a Spark SQL, querying the data using the Spark SQL, streaming. Okay, and then like how to run this machine learning at scale. Okay, and then this graph analytics. Okay, so these kind of core concepts you have to learn with respect to the Spark. Okay, now we look into how the Spark machine look like. For example, here is the Spark cluster. So in this Spark cluster, we have, for example, like okay, so we have a two workers. For example, before go there, I will jump into something the data flow what we are showing here. For example, right now we are looking into this Spark here. Okay, so right now we saw the Airflow, we saw the Jupyter notebook, and we saw the shared workspace here. Okay, so where we have this DAG and notebook related stuff, and then the Spark is also having an access to this shared row, and then this is a Spark cluster. In this Spark cluster, there are two workers. Okay, means when the Spark job is run on this here, this Spark will automatically assign the things to the workers. So in our case, we are using only one worker here. For example, if you look at here, there is only one worker here. Okay. So if you want to increase the number of workers, okay. So if you have enough hardware, like enough CPUs in the computer, for example, okay, you can increase this one in the using in the stack. So in the stack, if you look at the Docker Compose file, okay, so where we have about the Spark, I will show you that one as well. Okay, if you increase that one, then you will have a more number of more number of workers. For example, if you look at the Spark, for example, okay. So if you look at the Spark, okay, if you enable this Spark, for example, okay, if you enable this, then when you start the cluster, okay, or like the stack, then you'll have 2 workers. So if you want to add more, you just copy paste it and then you put the name like, okay, for example, like Spark worker 3, host name 3, okay, and the container number 3. That's it. Okay, so that like you will have a like more number of workers. In this example, we are just using one. Okay, because it doesn't matter how many workers when you're just learning it, but when you're running a large volume of data, you need more workers to run. So now you see that there is nothing is running at this time. So now what we are going to do is we are going to the Airflow and then we are going to trigger this job. So when you trigger this one, then as per the slides here, so when you trigger a Airflow, that particular will be executed on the Spark. This Spark will assign a task to the worker, and then the task will be executed there. Okay, and then the work will be completed. So what this one is doing is it is reading the orders from the database. Okay, not database, basically from the data lake. Okay, and then storing that data into a Postgres here, and then taking that one back into the data lake. Okay, so now let's go and trigger this job. So when I trigger this job, so it asks you, for example, like, yeah, so trigger it. Okay, now you see it here, like, okay, you see it here, then it start executing it. Okay, so we come to that place again. Let's go back to the Spark. Now I expect that particular job need to be triggered here in this worker. Soon we should see here running applications. Okay, so you see that there's already now started extract sales data. So now this one is running. Okay, so this one is running. So if you look at here, so the extract sales, and for example, if you click this one here and then click on the logs, so you can see that Spark job is executing. Okay, depend upon what code you have written, you may even see this, for example, the reading the data. For example, here you see it is reading the data because I used the print command there. That's why like it is showing it in the logs. Okay, then after that it will go to the transform sales data. Now we go and refresh this one. So we should see that now transform sales data. So it means that first task is completed. Now it's going to the transforming the data as per our things. Now if you click on that one, so maybe it might have changed again. Okay, so still it is doing a transform. Yeah, now that is completed. Now don't have, that means that this job is, I think it's completed. Okay, so yeah, it still is doing the third one. Okay, loading, actually loading is happening. So it means that still, yeah, load financial data. Okay, so this one is doing the loading job now. So once this is completed, for example, we see that particular task. Okay, now the task is completed. So it means that all the things like, okay, what we did is completed. For example, in the load data, if you go scroll down, maybe you see the aggregation has been happened. So it calculated for what reason, how much sales commission amount is. So it made a calculation and then we put the print command there. That's why like it is showing that information here. Okay, so what means that whatever the things you have written as part of the for the pipeline has been executed. This can be executed, as I mentioned, can be run in a intervals as well. Means that you can even do the scheduling. For example, if you want a schedule, you just go and copy this and put it here, then it will automatically run. For example, this schedule is a cron job, so this cron job runs like every 5 minutes once. Okay, so you can like this, you can create a cron jobs as per your wish, like daily once, daily thrice, every day. For example, this time. So whichever the things, like the way you want, you can write it, and then you can schedule the job into the Spark using this Airflow. Okay, so this is how, like, we write it and then we put it into the work in the Airflow. Okay, so the next thing what we look at. Stop sharing. Okay, so next thing what we have here is, now we went there and then we'll put the data into that one. Okay, so now there is a Kafka here. So what is this one? So next one what we are looking at is the Kafka. Let's look into the Kafka. Okay, so the Kafka, for example, as I mentioned, that used for capturing this real-time streaming data, okay, or like event data, for example. Okay, so basically what it will do is it will handle the millions of events per second. So that's why the Kafka is heavily used. It's one of the very good skill one should have. Okay, so basically it allows you to decouple the producers and the consumers. Okay, so it means that it need not to be a transactional. So you send, you get a response back. No, you can decouple the thing. So you send it, later on it will be done, just like your payments. Okay, when it is a payments, so you are a producer, means you are generating a amount transfer, and then the data pipelines consuming that particular transaction and doing the processing. So the producers and consumers. So this you can also use this enable the real-time analytics as well. You can also use this one for the real-time analytics, okay. So I mean, like, for example, how many transactions are happening, or on particular event basis, like that. So very high scalable and the fault tolerant. Okay, so it can handle large volumes of the data. So what is the core concepts in the Kafka is you should know what is the producer. Generally, data engineer will not do the producing job. So basically the developers, by writing a code, okay, of click on the browser some product, okay, then it will generate a event. Okay, that is a producer here. Okay, so we don't do that one, but consumer, yes, the data engineers will consume the data possibly, okay, for processing that one. So what you have to know about the topic. So for example, every producer will be connected to every producer or a consumer is connected to a topic. Okay, so by that way, you can categorize the data. Okay, for example, clicks will go to one place and orders will go to another topic or something like that. So you can read them. So broker is a Kafka server, which is maintaining these topics. Partitions, okay, these partitions enable the scalability and the parallelism. For example, let's say there are two consumers listening to a topic one, for example. When the order came, so those two consumers should not order. Let's say, for example, you are working in a shop, okay, along with one guy came, and then he want to ask you, he want to buy eggs. So you both don't go and bring the eggs, because he just need one egg, for example, one packet of egg. Okay, it means that if one person handles the eggs, okay, then the second person should handle the another one. Okay, so that is the parallelism here. Okay, so not that both persons go and take the order from him and bring two, for example, two packets of the eggs to him. Okay, so that is what's the parallelism here in the sense. Okay, so now look into the Kafka. So here in the picture, for example, so there's a Kafka, okay, where user activity, the user is doing some activity. He want to buy some products, so he will do the clicks on some products. He may buy or may not buy. At the end, what he will do is he will put it into the cart, okay, and then he will make an order. So either he click or not, either he buy or not, if he do the clicks, it will come to the Kafka. If once he made a cart and then he will submit an order, that will also come to the Kafka. Now we look into how the Kafka look like. Okay, so in this one, we have a Kafka UI. So in this Kafka UI, we have a topics. So in these topics, we have a orders and user clicks. So these particular stack also contains which simulating the user here, the user activity, which is sending the clicks and orders to the Kafka. For example, if you go into the Kafka and then look into the orders, for example, here. So here you see like right now we have like 692 orders. For example, if you look at the messages, okay, there you should see that okay, this is the order ID, customer ID, employee ID, for example, okay, shipping date, shipping via, and then the orders he's looking for. So you just ordered only one product, order ID and product ID. So as I mentioned, like if you remember the count, okay, previously, let's say, for example, go back to the overview. So now you see orders are 703. Previously, it was like 693 or something like that. For example, if I refresh this one, that number might be changed 703 to 705. It means that that particular stack, what we have is producing the events. Okay, so that like when you're practicing, you can see that live streaming of those into the Kafka where you can handle that one. Okay, so like that we have a topics of user clicks as well. For example, if you see that there are around like from the time we started this stack, so we got around like 10K messages into the Kafka. So if you go into the messages and then if you look at and then click on that one, you see, for example, okay, this is the timestamp when that click has happened by this session, okay, for this product. And what he did is he viewed the product by searching. Okay, so that is the click event. Okay, so using this data, you can develop some analytics or like management view or something like that. Okay, so you can generate whatever the requirements, the data engineering requirements we have for the business. You can develop that one. Okay, so this is the Kafka. Now we have the Kafka and we saw that like okay, what it contains. Now the whatever the topics data in messaging we are receiving here need to be sent to the, for example, like a ClickHouse. Assume that like our requirement is to send to the ClickHouse. So what is this ClickHouse? So before you look into the ClickHouse, let's go into the, for example, Trino. Trino is, for example, okay, Trino, as I mentioned that to QA a large volume of data, okay, which is there in the for example, like in the data lake or in the ClickHouse. So it is more like a centralized tool where you can connect to many things, not just only to the data lake. You can connect to the Postgres, you can connect to the MySQL, you connect to the MS SQL server. You take it any database, okay? So you can connect through the Trino, okay? So and then okay, you can connect through the Metastore as well. So this is the most powerful here. So Metastore, you can connect to Postgres SQL. They have their own clients. You can do that one. Okay, you can connect one way or other way. Okay, but connecting to the data lake. Okay, so through the Metastore. So I already told you about like what is the Metastore. Okay, so the Metastore is a catalog maintainer about the data. Okay, so for example, if you look at the Metastore here, so which enables like for example, like Spark, Rhino, Evo, Presto, okay, to access the data consistently and track the table structure and storage details without storing the data itself. This Metastore doesn't store the data, but it just only stores about the data, so that like you can easily access this data from the data lake. Okay, so the key concepts are like for example, you have to learn is like how to the concepts of storing the metadata in the relational databases, for example, exploring the like the Thrift API query engine, like okay, how this Thrift API works on the Hive Metastore, for example. Okay, this kind of things you have to learn, so that like the concept you have to learn, so that like you can easily access these Metastores. Okay, for example, let's jump into the picture once again. Okay, yeah, so jump in the picture again. So here, as I mentioned that like we have a Trino. Okay, so where you can access the through Metastore, we can access and then browse through this particular this thing. Okay, now let's go to Trino. Okay, so GUI. Okay, the Trino is the engine. Okay, so which is there running. So again, like admin here. Okay, so once you have in the GUI, okay, so this is a UI where you can see like, okay, depend upon what kind of a configuration it is provided. So here right now we have this Northwind database, okay, where you have these categories, products, orders, and all this stuff. And then we have the Trino, okay, Trino engine where it will connect to the meta store, and then it can retrieve the information. For example, if you look at that, Hue default is the default database we are here, schema. In this, we don't have any tables at this moment. Okay, and then we have a ClickHouse. Okay, so the ClickHouse, we have a default database which I created one dummy as part of a stack. Okay, it doesn't have anything, so don't worry about that until we create a table here. Okay, so the ClickHouse again is an engine. We don't have any specific UI or something like that. We can. There are many other UIs available, but it is a just like a MySQL. It's having a database, but is only a column-based database where you can store OLAP related data. For example, user clicks. For example, okay. Now we are going to add user clicks from Kafka to the ClickHouse using Kafka connector. Okay, so now we don't have anything here. Okay, so now let's jump. First, go and create a. Okay, now go and create a table. Okay, so first we are going to create a table in the ClickHouse. So what we are taking the default schema, and the table name is user clicks. Okay, and then we have provided a structure of this one, and then we are going to run it. So you may see one error. It's okay, no problem. Don't worry about this error, but still it will create it. Okay, you see there is a user clicks table is created with this schema. Okay, you see this name coins came twice. There's a bug in this one. Okay, so don't worry about it. Okay, still it is only one table. Okay, now we have a table here which is we created. Now let's query the table. Okay, so we don't have any records here because we just created a table in the ClickHouse, but there is no streaming is happening into the ClickHouse yet. Okay, so for that we are going to create a Kafka connected to the ClickHouse. So now we go here. Okay, and then here you see there is a Kafka connector which is stored in again like in the stack code Trino Kafka connector Kafka ClickHouse sync here. So we created here, so you can look into that configuration or like a connector by navigating through code. Okay, next code Trino. Okay, and then Kafka ClickHouse sync. Kafka ClickHouse sync. Okay, this is the connector. So what we are telling that one is ClickHouse is located here. Okay, and this is the database. This is username and password for that one. Okay, and this is the topic I want to read and then store that information there. So for that one, I just took this API, and then I'm putting it and then just adding it. Okay, so now what we did is to the Kafka, we created a connector to the ClickHouse. Now this will be pushing the data, whatever the clicks is created on the topic which we went through will be coming into the ClickHouse. Now you go here and then you run the same command. Hopefully we should see the data. That's it. Okay. Now you see we have the data here. So now you can run any pipelines on this data to read it, and then you do it like whatever you want using the ETL process. Okay, so that is how, like, you use the ClickHouse, and then you can run the queries. For example, if you want to understand this data here, maybe like you can run like based upon group by actions, how many are there, like how many, which is the biggest used product. Okay, you do analytics like whatever that you want. Okay, because it's already there in the ClickHouse. Okay, so that is what this do. ClickHouse. Now the second thing, like, okay, now what we did, we send a data from a Kafka live streaming into the ClickHouse. What if I want to send a this data, whatever you are receiving here, not into the ClickHouse but into the data lake, or for example like S3. Okay, from S3 folder, Amazon S3 folder, for example. Okay, then we have another connector. Okay, where you can use that. Okay, you can use that to put into that one. Right now we are already receiving the data. Okay, we are already receiving the data. Now this is a consumer. Okay, this is also a consumer. Okay, so now we have a connector. Okay, so now I'm also adding this one. Once I add this, then it will start pushing the data into the AWS S3. For example, before we even jump into that one, let's look what we have here. Okay, Kafka S3 sync. So what it is doing? So it is connecting to the local stack that is having the S3. Okay, and then under bucket name clickstream bucket, it is creating a topic called user streams. Okay, so before that, what I will do is I will check that what do we have there. So in S3, so right now we have in S3 ClickHouse bucket, clickstream bucket is there. Yes, we have that. Okay, now let's check what do we have in that one. Okay, what do we have in this one? Oops. Okay, what do we have in the clickstream bucket? We don't have anything at all here. Okay, it's an empty one. Now we are going to create a connector and then we are going to check it. Okay, so we are going to take a connector and then we are going to create a connector from S3 to, sorry, Kafka to S3. Now it should be sending the data already. Okay, now let's go and check this one. You see, there is a topic is created. Okay, now I'll go to the topic and then I will check it. Now we have the user click, the topic name. Then there's a partition. Now this partition will contain the data. Okay, whatever for every click, like it is generating or depend upon like, okay, how this particular is configured. Okay, so for example, here the flash size is 10. It means that it is having 10 clicks on each JSON file. Okay, 10 clicks on each JSON file. Now we have the clicks there. So now that has been delivered to the S3. Okay, now deliver to the S3. Okay, now you work on this particular thing and then you can access. For example, now we go back to the, okay, now we have that in the S3. Okay, if you go to Hui, for example, okay, and then you go to the for example Trino, and then you see here we don't have anything like, okay, we have HU default, but we don't have any tables. Okay, now we have this Hui connected through to the data lakes through metadata. We have a data there in S3, but we can't see anything here because we have not created any metadata yet. Okay, that is what we are going to create to. Now we to look into the data which Kafka is storing the data there. So we need to have a metadata, catalog need to be created so that we can query it. Okay, now let's look into that again. Okay, so now you go back. Okay, so now we are here. So to do that, first we need to create a. Okay, now we need to create a. Okay, I'm just creating one schema here. That is demo buckets clicks. Okay, I mean from there, for example. Okay, yeah, now I'm running it. So what happens is now if you look at here, it will create a new schema called Hive Clicks. That is the one like what we mentioned here, but it doesn't have any tables. Okay. Okay, now I'm going to create a table for that. So now I'm telling that this table I'm creating, the data is coming from the ClickHouse team topics user clicks. That is the one what we saw here now. Okay, I'm going to create that table. So with that location. So I'm telling that okay, use this location to get the data. Okay, it is not really creating, it is not really reading the data and then storing it. No, the data is only at one place. Okay, that is the place where the Kafka is stored. Okay, it is only creating a layer, the metadata information there. When you query it, you are still querying those files, not the database or something like that. Still, it is you are querying the same data what we stored, the JSON data, not the table. We are not converting anything. We are just reading those things. Okay, now you execute this. Okay, now the table is created here. For example, user clicks. Okay, now if you try to run any query, you may not get anything. Okay, just to show you that. Okay, now you can't see any data. Okay, because see, you can't see any data. Why? The reason is it is in the partitions. So we need to make sure that like it understands the partitions as well. Okay, that's why we need to add a partition information as well to this one. So the partition is okay. Now we are telling that okay, use the partition for this one. Okay, so or this like partition metadata. Okay, now the partition has been added. So it means that now it recognizes there is a partition. Okay, so now after that, what you can do is whether, for example, if you want to see how many partitions are there, for example, you can just use this SQL. Okay, and then run. It will show that like okay, how many partitions you have. It says that like you have only one partition, that is name is the partition 0. Okay, now go to the history. Then I'm just taking the old query back. I don't want to again like do that. Yeah. Okay, now I'm going to execute this one. Now we should see the data which is coming there. Okay, now you see like data is coming. So for example, let's see count star from this table. Let's see how many are there. Okay, it says that like you have around like 15,490. Okay, so just run it again. Or maybe like just a couple of seconds. Just we run it. We should see like 490. We have like 15K 490. Now we see how many we have there. 15,590. Okay, so 100 more. So what happens here? So the user activity is creating the clicks. Okay, and then this Kafka sync connector is pushing data to the data lake. Okay, and then we already have this metastore created for that particular purpose. Okay, and then it is reading the data and then it's showing that in the UI. Okay, that is what it happened there. Okay, that is what it happened. Okay, now we saw that like okay how it is. Okay, how it has been into that one. Okay, so now so we have covered the we have covered the ClickHouse, we have covered the metastore. Okay, Trino. Okay, now let's look into the superset. The superset. So superset is basically used for the visualization purpose. Okay, so means that like when you have a large data, so for example like a ClickHouse, for example, okay, you can query the data from the ClickHouse and then you can create any visualization charts, for example graphs, if you want. Okay, so now we for that one, all you have to understand is how to use the superset. This is again like not a super complex. All you have to, if you know how to know about the charts or something like that, Excel, for example, charts, for example, the similar way you should know by using the queries, you can create charts. So you will learn what is like superset, how to create the charts from the superset. Okay, now we have a, for example, like the superset here. Okay, admin. Okay, so now this is a superset, like where you have a SQL. Again, you can run the SQL commands, and then you can create a data sets to create a charts. Let's first explore this SQL lab. So this one has been again like connected to the Trino, because like the metadata. So in this metadata, we have a click stream. Okay, in this one we have user clicks. Okay, so in this user clicks, like we have this table. So you can also run the query as again here if you want. For example, the same information what you get it. So you can do some analytics here. First, take like whichever the things you want before you create some kind of a a charts or something like that. So if you are decided that like you want to create a charts, so every chart contain a data sets. Okay, so you go to the data sets and create a data set. Okay, so take ClickHouse, take the default. Okay, and then take these user clicks. Okay, and then create a data set. Okay, so you take that one and then select the chart, for example. Okay, create a chart and then you write a queries here. Okay, so I put somewhere the query so that like okay, to make it simple. I'm not okay, so super expert on this one, but I know what to do. Okay, so you take like okay, what need to be the in the x-axis, for example. Okay, so you have like 7 columns. So what you want to be in the column is the timestamp. Okay, and then you take the dimensions. Okay, so I want the product ID. Okay, product ID. Okay, so for example, just let's and then metrics. So I want to count. Okay, and then create a chart. I'm just creating a very simple chart here. Okay, so yeah. Okay, so each timestamp, like how many, that's huge, I know. Okay, so I'm just showing that like okay, so you have to put a proper filters and all this stuff so that like you get a meaningful chart here. But the idea of the superset is that okay, so you have a big data, you have the pipeline, you process it, and then when the golden data is created, like as we discussed in the slides, in the Mendelian architecture, when the data is reached to the golden, okay, then use that golden data to represent the business analytics. So that's the idea of the superset here. Okay, so now we the picture. Okay, so it's the picture. Okay, yeah, oops. Yeah, sorry. Okay, so is the picture. Okay, yeah. So in this one, like we saw mostly like all the things here. Okay, so before like we do the little bit ending of that one. So let's go back to the initial one, that is notebooks, Jupyter notebook, for example. Okay, so where is the Jupyter? Yeah, this is the Jupyter notebook. Okay, now we have here, for example. Okay, so now we have here. So what this one is exactly the same again, like one particular Spark job. Okay, so what this Spark job do is it will go to this folder. Okay, for example, in this picture, you see there is an external here. Okay, what it means that is assume that there is an external system where you are a warehouse, you are working like as a third-party warehouse. Okay, you will get orders. So then you have to process those orders and then send it. So for that one, what they do is every day end they will upload the files to your some specific location of your data lake or somewhere. Okay, and then you process them. Okay, so in this case they uploaded a file called orders.parquet files into your system, and then you are running a Spark job to process those and then use that one for example, analytical purpose or like for a delivery purpose, whatever it is. Okay, so that is what it do here. So for example, let's assume that, let's see if there nothing is running here. Okay, we go to the, so what it is doing is it is reading this file, okay, and then showing that whether it has read the file successfully or not. Okay, then what it is doing is it is going to default not win orders new. So it is going into the meta store, and then in the Hive default, or like, the default schema, it is creating a table called not win orders underscore new with the data what it has read. Okay, so now we go to here, and then we see here there is no table. Hive underscore default, there is no table here. So this is okay. So this is going there, and then it is creating it. Then once it created it, again it reading the data, whether like, we are just verifying it, whatever the data we have written is retrieved or not, and then we are showing it the same data here. Okay, so that is what it means, that by the time we run this job, we should be able to see a table there in the meta store. Okay, and then that table contains this data. Okay, now let's run it. Okay, now we go to the Spark. We should see the job is started here. See, running. Yeah, okay. So it started this job, or like process Spark job. Okay, so then next one, read it. So it's reading it now here. Okay, it read, and then I'm writing now again to the, okay, writing to the meta store. Okay, so to the data lake basically. Okay, so now I written that. Okay, now if I go to the here, and then see, now we got this north wind. Okay, so now we have the data. Okay, so Hive. Okay, sorry, now. Okay, this one. Then if you select start from, okay, not in order new. Now you should see the same data, whatever the data like we have read here. Okay, so the data should be available now in the, for example, like the data lake, where you can query and then retrieve it, and then or like use this one to show the in the, for example, superset. So now I will go back, and I will try to read that one. For example, I will go back to the data sets. Okay, create a data set. Okay, use Trino. Okay, use default. Okay, not wind. Okay, so create data. Okay, now create a, for example, like yeah, bar chart. Okay, table x-axis. Maybe I will or product ID. Okay, I'll take a product ID on the x-axis, and then count how many, count dimension. Okay, count orders. Okay, each product, how many orders we get. Okay, so okay, so what is missing? Metric, yeah, count, save. Yeah, okay, so now let's look at the data. What kind of a chart it will create? Okay, so it also like created why we have like, okay, so x-axis is the product ID and the dimension is order ID. Okay. Maybe I'll just put that one now. Okay, so why there is no group by product ID? account. Okay, so maybe I will take just a small set. Okay, just to make simple. Okay, like okay, for example, don't worry about the queries. Okay, but yeah, so like this, you know, you can process that data and then bring the data into the visualization. Okay, so this is the overall like how we can load the data, how we move the data from one place to the another place. Okay, and run the pipelines and then make it the thing available. Okay, so this is all we have. Like okay, so we have 10 minutes left. So I just if you have some questions, feel free to ask me. Okay, so tag this company, Epireum Consultancy. I will share this one as well. Okay, so that it will help us to just to promote ourselves to that, like okay, our thing. So many workshops are coming. For example, if you go to Epireum.com, okay, and then you see the free workshops. So for example, you see here many workshops are coming in the near future. Okay, so yeah, you can enjoy those workshops now. Like we have like specific things as well to teach ClickCode, to teach Superset, okay, like this as well. Okay, so those things are coming. Okay, so yeah, you can if you. Thank you very much for all of you.